Welcome to Anjan GCP Data Engineering. So in this video we will see how we can process stream data which is coming into PubSub topic using Dataflow, right? So I've already done few videos on this topic already, but there we were using different sources, stream sources, but here we are using some a Python program which would generate some streaming data. Okay, so let us quickly move to the demo slide actually. Okay, here what we'll do, we are going to use Apache Beam Python notebook for this demo. So there actually we will use this notebook for two purposes, right? The first purpose is actually, so whatever the our Apache Beam pipeline, right, we have developed to demo this concept, right? So it has been developed and tested in the Apache Beam notebook, right? We will test it in Apache Beam notebook. Actually we'll try to see the transformation which have been applied on top of P collection one by one in sequence to understand this pipeline in a better way, right? So this is the first task. Okay, and the second thing we are basically going to perform on the Apache Beam notebook is a Python stream data generator. Actually we have written a simple Python program where it will try to generate stream data. Basically there we are using some range function to generate random numbers along with the timestamps. So I will try to explain that program, right, in when we are basically performing that demo. Okay, right. So now our Apache Python Beam notebook, right, it's going to act as a publisher which would basically publish a message to the PubSub topic in a stream manner. Okay, then we'll publish those messages to one of the PubSub topic which has been already created for this demo, right? So then we have our Dataflow. Dataflow will act as a subscriber, right? So where it will try to receive the messages from PubSub topic in stream mode, right? Then we are going to perform some transformation on top of streaming data. So we will use all the concepts which are related to the windowing, right? So in this demo we are going to use fixed windows concept, right? We'll try to read stream data from PubSub topic and we'll try to basically group them, or we'll try to count the number of element per window, and then we'll try to write the data into a BigQuery table, right? So this whole thing is a pipeline, right? So right, in the PubSub terminology, our Python stream program is acting as a publisher, right, and Dataflow is acting as a subscriber. Coming to the Apache Beam pipeline terminology, so PubSub topic is a source for us which would continuously send messages to the Dataflow to process it, right? And we do have a sink which is a BigQuery, so where we are going to insert our transform data into BigQuery for further analysis. So this whole thing is a ETL pipeline, right? So Dataflow is acting as a ETL tool for us in this case. Okay, now quickly go to the demo, and then we'll try to perform these tasks one by one. Okay. Okay, first of all we are into PubSub console. So this is the topic which has been created for our demo purpose. So our Python stream program is going to continuously publish messages to this topic. Okay, so our Dataflow is subscribed to this topic which will receive stream messages for further processing, right? Okay, so then we'll move to our Apache Beam notebook, right? This is the Apache Beam notebook which has been already created. So the same notebook we have used for different demos when we were demoing different concept on Apache Beam, right? So the same notebook we are using here. Okay, so first of all we'll try to understand our Python stream program. This is a simple program. If you just go to my previous video, the same program I've been using here. So I've been using PubSub API, Python API, or Python client libraries, right? So then what I'm trying to do, this is our project and this is our topic, right? And then by using publisher client, right? So and using Python range function, I'm trying to generate numbers from 1 to 99, in between 1 to 100. So what I'm trying to do, for each number I'm trying to append even date time, right? So I'm trying to publish this data with 1 second delay every time, so that it will get some time to get published to the PubSub topic, right? So we'll see how this message look like, right? So in demo, okay, this is a simple Python stream program which would publish messages to the PubSub topic, right? Now we'll go to the Dataflow basically pipeline, Apache Beam pipeline, right? So this is the program which we are going to run it on the Dataflow environment, okay? So it look bit lengthy, so what I'll do, so I'll try to explain this program in detail. So basically I would like to demo each and every step which we are going to perform as part of this pipeline, right? So by using direct runner or interactive runner, which is a part of this Apache Beam notebook, right? So but this is the program which we are going to launch on our Dataflow, okay? So this program actually reading inputs from command line argument, right? So we'll try to launch this program from our Cloud Shell environment. That's why I've just coded like this. So it is reading two inputs, mandatory inputs from the CLI, which is PubSub topic, from where it is getting the messages, and also output path also mandatory. But though we are not using this particular option in our program, but it is mandatory to mention that output path over here, okay? So then coming to the pipeline, right? So in the first step, this is the step which we are going to perform, right? We are going to read data from PubSub topic, right? So PubSub topic will get the messages from our Python stream program, right? So basically we will receive those messages in the byte stream format. That's why in the second step we'll have to decode it to the string format, okay? Then once we decode it to the string format, we'll have to split that string such a way that, so anyway we'll have a random number inside it, okay? And also we do have a timestamp. We'll have to basically parse the timestamp and we'll have to convert it into date time, right? Then anyway it's a unbounded data, it is a streaming data. To process streaming data, it is mandatory to have whatever the elements coming in the P collection, it should have a timestamp associated with it. That's why by using this particular transformation timestamp value, we are just assigning a timestamp. We are using the same date time and converting it to a timestamp and assigning it to a element. So we'll have a event number and associated timestamp with it, okay? And then we are dividing that entire P collection into fixed windows. We are using fixed windows concept as part of our stream data processing. I've already discussed all these concepts in detail in my previous videos. So we have one video called Apache Beam Windows concept, where I've explained everything, fixed windows, sliding windows, right, and other window concept. Just go through that, okay? So in this pipeline we will divide that P collection into fixed windows, which is having 5 seconds duration, and then we'll try to count number of elements per window, right? So that's where we are using combiner count globally without default option. This would basically count number of elements per window, right? And then we need to write the transform data into BigQuery. Before writing into BigQuery, we need to basically format it such a way that user can understand what we are going to write into the BigQuery. That's where I am using a Purdue, a user defined function. Basically, so once I get the count per window, I would like to append even that window start time and window end time by using this Purdue function. So let us go to that function over here. This is the function. So this will be applied on top of this P collection, which is coming out of this particular transformation count globally. Then what we are trying to do, so we are just taking the number of elements per window from this transformation, right, and appending it with the window start time and also window end time with hyphen as a separator, right? Now this is a string, right? Okay. Now, so it will be like more user readable format. Once it is coming out of this transformation, it will be in more user readable format, so that it will have count and also window start time and also window end time. Okay, and then in order to write something into BigQuery, it should be in a JSON or dictionary format. We need to convert the data into a dictionary format. That's why what I am trying to do, I am just reading the data coming out from this particular transformation and then converting into a dictionary format, right? So my BigQuery table will have only single column, that is window count and then data, right? So that's where you can see window count, it's a string, right? So then we can write the data into BigQuery table. So that will be this will be in a stream mode. So we are going to launch Dataflow stream pipeline. Okay, so this is the high level explanation of this pipeline. Now let us go to our so the same pipeline I have over here. So just to explain you, right, what I'm trying to do. So I'll try to trigger this program which would continuously publish a message to the topic, and then I'll try to execute this pipeline by commenting certain part of this pipeline, so that I will try to show the data as part of this P collection in sequence. How it look like in this P collection, how it look like in the second P collection, how it look like in the third P collection, everywhere, wherever it is required, so that you will get some clarity and good understanding about this pipeline, how it is working, right? So let us quickly go to our Python program. Before that, let me comment out certain part of this pipeline. Okay, here. So first of all, we'll try to see the plain data, how exactly it is coming from our PubSub topic. Okay. Okay, so now you can directly, so I'm using print function to see how the data look like. Okay, so let me just restart the kernel every time, because I will use this option every time. Sometimes what will happen, right, when I run this first step and when I'm going to run the second step, just by uncommenting certain part of the code, there will be a data overlapping. So in order to avoid that, let me every time restart the kernel, so that you can only see the required data. Okay, now let me go to this program, just trigger this program. Now this will continuously see, it's a byte stream, continuously publishing messages to the topic. This will look like this, event number and the timestamp. Now let us go and trigger this direct runner pipeline. Okay, this is an interactive or direct runner. Now you can see it's a byte stream directly coming from this Python program, stream program, right? It would look like this, it's a byte stream. So right, so let me stop this and also stop this. Now what we will do, anyway it is in a byte stream. Now we'll have to convert this data into string. For that we are applying the next transformation, that is decode to UTF-8, right? Now again restart the kernel to clear the previous data. Now again just start this program, go to our pipeline, now trigger this. Now you can see this will be converted into strings. Now it is in a string format, event number, timestamp, event number, timestamp, right? So now let us stop this, again stop this. Now the next transformation, anyway you know I'm going to split this string into two different things. One is event number, right, by using this transformation, right, just split it and convert into a dictionary format, right, event number and event time. This is event time. Now anyway it is string, this is in a string representation format. Now we'll have to convert this string representation format into date time. So for that I am using our Python date time module, right? By using that module or method, I'm converting into date time, right? But anyway, in order to associate any timestamp with the event number, we'll have to convert again that into timestamp. I am doing that in a next transformation. Now let us again, we'll see how this output look like. Let us restart the kernel. Now again print this or generate the stream data. Now trigger our pipeline. This demo is going to be a bit lengthy. Please be patient and you will have you can learn so many concepts actually. Be patient. Okay, see how it look like. Okay, let us stop. See, event number, right? This is in string representation, and also event time. It has been converted into date time, right? Now in the next transformation, this will be converted into that every element, that is this event numbers, will be associated with timestamp. If you try to print this output, this will only print only event numbers, not the time. So internally it will be assigned with the event number, every event number, but you will not be able to see this timestamp coming up, right? Let us try to print even this transformation output, how it look like. Okay, let us go and again trigger, right? Now run this. See, only even numbers you can able to see. Internally already timestamp has been assigned to each and every event number, but this will not be printed. Okay, just it's a implicit actually. It has been already assigned to each and every element, right? Okay, stop this. Now next one, we'll have to divide this stream of data into fixed windows, which is having 5 seconds in length or duration, right? I don't want to print this output anyway. It is a very important transformation which would require to process stream data. Next, count them. Once you divide them into fixed windows, we'll have to perform some aggregation on top of elements which are part of that window. So what it will do, it will just count number of elements per window, right? Now just try to print the output of this particular transformation, right? Okay, now restart kernel, right? Now again, yeah, now my stream data has been started publishing to that PubSub topic. Now just run this pipeline again. It would look like, now this will have output from this P collection, that is number of elements per window. You can see in the first window we have 4 elements. It's a plain output, right? So it will be a bit slow because it has to perform that aggregation, right? Count, and then it will produce that output per window basis, right? Now you got it, right? Yep. So next step, now anyway we have the aggregated count or count per window, right? Now I would like to print it or format it in more user readable format, right? This is having plain numbers, which is not, I mean, we don't know, right, what it is. So that's why what I'll do, by using this purdo function, I'm just trying to append even window start time and window end time of each and every window, fixed window, right? So and then also count, right, which is associated to that window, or the count which belongs to that window. Okay, now let us try to print this output which is coming out of from this purdo. Okay, let us go and restart our kernel. Okay, now run. See, now it is in good format actually. We can understand it in a better manner, right? So we have count of that window. We have 4 elements in this window. You can see 5 seconds duration. Each window is having 5 second duration. 50, 55, 55 again 0, 0, 5, something like that. So you can see the first window is having 4 elements, second window 4 elements, third window 5 elements. Now it is in more reusable format, right? Now I'll have to write this data into our BigQuery table, right? For that we'll have to convert this data into dictionary format by using this. I'm using this map lambda, just converting into dictionary, right? Let us try to print this output, how it would look like, right? So let us restart our kernel. Let us go to this program again start this program, right? Now run this program. Now you can see this output in a dictionary format, which we can write the data into BigQuery table. This table you can see what count 3, window start time and window end time. So we can write this data into a BigQuery single column table, right? I hope you are clear, right? Now what we can do, we'll try to, let me stop this, let me also stop this. So this is the same program, I just modified it such a way that it can take argument from the CLI. So what it will take, basically it will take this argument, right? So we are going to run this commands or this pipeline from Cloud Shell. So it will try to take input topic, right? This is the input topic we are using, right? I've already discussed. This is output path, it's a mandatory for the pipeline. So we are not using it in a pipeline, so we'll have to mention it. And then the project where we are going to run this pipeline, and also region where you are going to run this pipeline. From this region itself, our Dataflow workers will spin up and will process our workload. And then the temp location, so whenever we launch a Dataflow pipeline, Dataflow will write some internal file into this GCS bucket path. Then we'll have to mention the runner. So we can also mention other parameters which are required by this pipeline, right? But for this pipeline we need only these parameters, right? You can see. So this is the code. So this will basically read input from the command line argument. You can see this is the same pipeline. So this is our BigQuery table stream data, right? And this is the data set and project schema single column table, it's a string, right? I'm just using create if needed. If that table is not available, we'll have to create it, and if it is already available, then you'll have to append it. Okay, now let us go to the BigQuery editor. You can see this is the data set. Once you launch your pipeline on the Dataflow after some time, so then you can see stream data coming into transformed stream data coming into this data set. That table will be created and you can see that stream data. Okay, so I have some limitation and stream data insert into BigQuery. So we can see some error after processing some data. So but anyway, we'll see that. Okay, now what I can do, I have this reconnect. We'll have to connect our Cloud Shell. Right, I have this program already available over here. I mean pipeline. This is a pipeline, right? So same thing, this one I just copied it to my Cloud Shell environment. So I'm just trying to run this pipeline using this. Okay, commands, right? So let me run. Now it is running. So soon we can see that job is running in our Dataflow environment, right? You can see this job has been launched, Beam app. So you can see this is streaming, right? So let us go to a pipeline where we are mentioning those options, right? In the pipeline options, right, over here you can see we are reading argument from command line interface and the job type is stream. We are also saving main session. Okay, so again go to our job interface in Dataflow, just click on it, close this. Now you can see this job has been running. It will take some time, maybe 3 to 4 minutes to see that stream data coming into our BigQuery table, right? The table is not yet created. It will be created by our this thing, okay, our pipeline. Nothing, right? Now workers are available. There is one worker is already spinned up and running. Now let us try to publish messages to topic using our stream program, right? Now we'll have to trigger this again. Yep, now we should be seeing this data coming into our pipeline over here. Now you can see here somewhere here it will be displayed just by saying streaming data or something. This is still running. Now our stream program is continuously publishing message to the topic, this topic, right? This one, sub data flow. Now our data flow is trying to process those using this logic. It will apply this series of transformation one by one, as I already explained in my direct runner demo, right? Now let us go to our pipeline, graphical representation of our graph view of our pipeline. So you can see read events from the topic, convert to string. So again dictionary format, assigning timestamp to each element. Now dividing that pipeline, that p collection into fixed windows. Now trying to calculate number of elements per window, formatting the result, right, such a way that we will append start timestamp of a window and also end timestamp of a window, and then converting that into dictionary and then write that into BigQuery. Here we are converting into dictionary, then writing that into BigQuery, right? So how much time? It's 2 minutes since we just triggered our job. Now we should see, I think we have already published. Let me again trigger this. Sometimes there will be some delay. Again trigger this program so that it will again publish the messages, right? Now you can see stream data coming up. Total stream data processed 174.99 kilobyte, right? Now you should see the table is getting created or got created at BigQuery data set. Now you should see that data streamed into the table, okay. See, this table has been created, stream data. Click on this table, okay. This is having only single column. Go to the details. You can see 25 rows are coming in already. This is stream data, right? You can see this will look like that. Same output, number of elements per window. This is window start time, window end time. So each window is having 5-second duration. You can see number of elements. So this is how in real time streaming data processing will take place, okay. So this is a simple demo. Actually we are just calculating number of elements per window like that by using any window concept, fixed window, sliding window, overlapping window, right, or session window. You can perform any aggregation based on your requirement. And also always remember, in order to stop streamed data pipeline, right, so you will have to come here and click on this stop button. So actually I already clicked on it, so that's why it has been already in a disabled mode, right, in a gray. It has been converted into gray color, right, otherwise it would have been in a green color. So once you click on it, you will get an option saying either cancel or drain the job. So always go for clicking on drain. So drain is a soft exit, cancel is a force exit. Always go for drain job, so it will be drained. You can see this job is drained, right. And also I would like to show something in PubSub topic, that console also, the PubSub console, right. Just come over here, click on the subscription. You can see there is some subscription has been created. You can see, because since we are using our Dataflow to process the stream data, you can see PubSub Dataflow demos, there is a subscription for Dataflow has been created, okay. So this is what I would like to show, right? So I hope you understood this concept. So thank you very much for watching this video.